Good evening, all. Firstly, thank you everybody for coming here. Thank you all the participants. I hope to meet each one of you and learn something today. And thank you, Sagar and Soju Academy for the opportunity. So when Sagar reached out to me asking to come and talk about the topic, I was thinking, what should I talk? Should I talk something with AI or should I take a topic outside of AI, right? So I could not really think of a topic that I could do without AI because AI has been making massive impact. It's helping us with productivity, helping us with a lot of things. So I could not really think of picking a topic, beyond AI. So I just had to stick with the topic with AI, especially around the performance testing. Performance testing is one which is closer to my heart. And there's a lot to learn and do with performance testing, especially with how AI is actually making changes today. So before we deep dive, would you like to play some game?
Yes.
Wow. Good. All right. I'll not take more than 3 minutes for the game. We'll stick to 3 minutes because of the time runs. Okay? We'll divide to group A and group B. Just pick a name for group A. Team name. Team name for group A. Anything? Cheetah? Cheetah. This team? Panther? Okay, Panther. Okay, the game is very simple. The rules are very simple. We have all played this game. Name, place, animal thing, right? We have played as a kids, we have played with our kids, and we still play with other kids as well, right? Name, place, animal thing. But we'll stick with name. Okay, just name. Name pertaining to AI domain only, right? If I say NLP, right, it ends with P, give me a name with P, right? So AI domain only. Okay, we'll start with this team. Pick a name. Cheetah is not related to AI. Pick a name. Okay, I'll give a name. ChatGPT. T.
Gem.
T.
T. Transform.
Transformer. R.
Revolution.
Sorry?
Revolution.
Revolution? What revolution?
Replicate.
T. T. What? One? None. You cannot do it.
Tokens.
T.
Tokens.
Okay. Yeah.
Futures. NLP.
NLP. T. Python. Very friendly. Perplexity. Okay, I can take that. Why? Why? We're not going to get more than 10 seconds. Why? Anything to do with AI domain with why? Tick 1, tick 2, tick 3, 4, 5, 6, 7, 8. Why?
Forest no tick.
Sorry?
Forest no tick.
Tick 1, tick 5, tick 6, 7, 8, 9, 10. 50 minutes to get. Thank you. All right, moving on to the next slide, performance testing overview. How many of you have worked on performance testing, or how many of you have background about performance testing? Okay. Okay. I'll try to keep it very, very simple because this is going to be technical, but nevertheless, I'll try to keep it very, very simple so that everybody can grasp what I'm talking about. So a quick overview on the performance testing. When I was working as a developer many years back, we were building a feature and we had to roll out that feature. So I was talking to my manager. I said, we had to really do performance testing. Why don't we just do additional hardware and just release the product? Right? So why do we have to spend time doing performance testing? He said, it's not going to go that way, right? I mean, it's going to be different. I mean, you can't just keep performance testing and throw hardware at that. But he did tell me that, okay, go try it out and figure out what would happen. Right? So what I did was, we went ahead, we did not do any performance testing, we skipped it, we released the product, right? It was all good. I was so happy that, I made a decision which was kind of right. I mean, just throwing additional hardware at it and not having to do performance testing, it was all going good. Until late night, somebody called me and said, there's a breakdown in the production environment. I was like, what happened? It was all working from morning till evening. What happened late night, right? Then we had to quickly connect and look at what's happening in the product environment. So what was actually happening in the product environment was, though we had given additional hardware to deal with it, there was a connection leak, database connection leak, which we had forgot to close in our code. As soon as we were working with the database connection, we were not closing the code, right? So it was just spanning a lot of database connections, and it just ran out of database connection, right? So no matter how much hardware you threw at it, it would just shut down, right? Because of the leak in the code, right? So that's where I understood, you just cannot throw hardware and skip performance. It doesn't work. So that was the hard way of learning, but that's the reality. A lot of times we think, can't we skip testing? Can't we, cut down the cycle time of how much time we spend for the overall testing, performance, security, or whatever it might be? It just doesn't happen. Right? Same way with performance. Performance is very, very important. We just cannot afford to skip it. So, talking about the typical performance testing process, even in today's AI era, still the core traits are not really changed. Right? I mean, with AI, some of the things we're able to accelerate, some of them we're able to improve the overall productivity, but the core things have remained the same. So we work with the product management team to gather requirements on identifying the critical scenarios that are important from business standpoint, important from customer standpoint, important from architectural standpoint, right? You got to identify what are those areas, what are those test cases, or what are those critical scenarios that are important from that aspect. So we work with the product management team to identify those critical areas, and then we come up with the requirements, right? So once we come up with the requirement, we're going to define something called service level agreements, SLAs. So as soon as you're going to tell, this particular order management has to support 500, probably concurrent users with a TPS of, 100 per second, 1,000 per second. And so you're going to fix SLAs for each of these critical areas that you're going to be identifying. Then you're going to work with the test, then you're going to work with the IT team. I mean, way back, probably 10, 15 years back, or before the DevOps, right? We all had to work with the IT team to identify the test environments because we had to put in a ticket and they're going to tell us, it's going to take 1 month to get the environment, right? Today it's not the case, but that was the case 10, 15 years back. So we had to, think of test environment, how closer can we get to the prod environment, how do we do that? Everything we have to think about it. Right? Then, script development, using load runner, JMeter, think about, how do you develop the script, how do you correlate the script, how do you build the scheduling, and things like that. Test data is another important area because performance testing is a data testing activity. It will require tons and tons of data. So data was extremely important, which we had to meticulously plan. And then lastly, you have to define, how the execution is going to be, right? I mean, you're going to run like an hour test, 5 hour test, 10-hour test. It could be endurance, so load test, stress test, or whatever, right? You got to chart it out, and you got to have it planned. And lastly, you'll also have to involve, architects, database team and developers and many other people in terms of collaborating and fine tuning what you're going to find out, right? The hotspots, bottlenecks, and everything. We've got to come together, look at, analyze the report, fine tune it, and then read it. So this is the typical performance testing cycle that we still follow. Like I mentioned, AI has made a massive difference, but more or less the cycle still remains the same. So going back to the story with my manager, I was always wondering, can AI really get rid of performance testing? Right? Probably in 2040, looking at the way how AI is evolving, probably we may not have to do performance testing. I might be wrong, but if that happens, it's going to be good. I mean, probably testers can focus on a lot of other things. How can that happen, right? How can that happen? If you look at the performance testing, right, there are three aspects to consider, right? One is actually, finding a entire system, right? So the system can comprise of web server, database server, app service. You could have various services like queuing, notification, and a lot of other things, right? Tracking, and, you can do anything, right? Performance system, right? So overall, if you look at, the system has to perform well. The system has to do well, right? To do well under what condition? Under the conditions of normal load, extensive load, abnormal load, or whatsoever, right? So the overall thing is, the system has to work well, when it's being stressed under a given condition, and it also has to return back to the conditions that it earlier had, right? So looking at that way, right? If AI can figure out a way to fine tune the system all by itself, right? Let's say, for example, on a Black Friday, what would happen? On a Black Friday, hundreds and thousands of users would start, putting load on the system, right? Like Big Billion Day, Flipkart, right? So Big Billion Day, what would happen? A lot of people would come to Flipkart to shop around on the Big Billion Day, right? So if AI can figure out automatically to lessen the impact or detect the anomaly and also figure out a way to fine tune the system, probably AI can help them. So again, the key takeaway from this slide is the performance tuning happens across few core areas like database, it could be related to configuration, it could be related to architecture, it could be related to code, or it could be related to infra, right? So if AI can actually fine tune all by itself, based on the load it's going to foresee or based on the current load that it can see, then probably AI can definitely cut down a lot of effort that we are spending on performance here. So what are the challenges that we have in performance testing today? So there are certain challenges that we still have with performance testing today. Of course, coming up with a realistic scenarios is definitely a very, very big challenge. Load generation and dynamic input modeling, that is also a challenge. Infrastructure environment, that's another challenge that we have. So again, I'd like to talk about a particular situation here around the environments. When I'm working on a product development for one of the largest edtech domains, so we were building software that would get deployed in world's largest schools and universities like Stanford, MIT, and many other universities. So we were working with one of the customers where we had to deploy our product. So basically, what the product will do is the product will help with student registration. For example, if we were to deploy the product on product in MIT, what would the product do is it will help with the student registration. So the students have to come to register for various classes like you had physics, biology, and whatsoever, you could come to the online registration. So we had deployed the product on one of our biggest customers in the US, and we had the registration day that was well planned. So the actual registration day came in, and the registrations were happening, and the system actually crashed. And it got escalated to the highest level. And we all had to huddle up and we got into a meeting to kind of do a postmortem. Why did it happen, right? Why did it happen? Because we had done extensive performance testing in our test environment. We had certified that our database could handle 10,000 TPS. Our concurrency scale was pretty much decent. We could scale up to 50,000 to 1 lakh users. And we had a good number of hardware footprint that we had established. So everything was fine on the testing side that we did, but on the production environment, it actually grew. So it got escalated to the highest level. They were frustrated. They were yelling at us, telling that we're going to cancel this contract, which would mean we're going to lose millions of millions of dollars of contract value, right? So during the postmortem, what we understood was the kind of hardware scale that we had was very, very limited. We did not really test with the actual clone of a production environment. That's one thing. Another thing was we also did not simulate the right user model or workflow pattern that we had to establish. We really had failed at it. Then our manager said, what can we do? I told him that probably we should test at a similar scale of production environment. So he said, go do it. I told him we cannot do it. Why can't we do it? I told him, I have to put in a ticket and it's going to take 1 month for IT team to give me the environment back. He said, what 1 month? I told him, yes, that's how we are working. I mean, we cannot get environment, whenever we want, right? So that is how it was. But we figured out another way to do that performance testing and action to our environment and satisfy the customer, fix the problem, and get away with the escalation that we had. But the problem still remained. I mean, we could not get infrastructure whenever we needed. I mean, even if we had to bump up memory from 4 gig to 6 gig, we had to put in a request, wait for 2 days for that to happen. Right? So that was the biggest challenge and blocker that we had. So how did we overcome it? Again, another story. When the cloud era started way back in 2010, we were the first one to embrace the cloud. So we started working with AWS Cloud. So we were really perplexed with the capabilities that cloud was offering. We could create our own environment. We could scale the environments. We could pump up the CPU, memory, and everything, right? So I told my manager, this is a beautiful opportunity. Why do we have to be dependent on the IT team? Why do we have to even put in a ticket to get the environment I would need, right? I told him, I will learn whatever it takes to get onto the cloud, build my own environment. So I'm not going to be dependent on any third-party team who will define my structure, right? So we started building our own environments. In fact, we got to a point where we were able to build a full-blown environment. We were able to set up the pipeline to build a full-blown environment. So what started as an example with one team eventually became the norm of the entire company. So entire company, all product lines, they were building their own environments to conduct performance testing. So even today, that's the norm of the company where teams build their own environment to conduct performance testing. And unfortunately, I think a lot of companies and a lot of teams still struggle with the testing environment. But that's how we got rid of testing environment. And test data, last year, just touched upon test data. Test data, we need loads and loads of test data. So how we were able to overcome that? We were able to get loads from production environment, scrub the data, use it in the test environment. So it had millions of records, we had to clone it, scrub it, and put it on the test environment. Anybody like to highlight any of the challenges that you guys have with any of this? Go ahead.
Yeah, one issue I faced is data swapping. I was working for one. Yeah. Yeah, one issue I saw when I was working on performance testing is data swapping. I was working for one of the leading healthcare application where whenever the load testing we do, right, the data used to get swapped. Consider like I'm a patient and there is another patient. If I log in, my user details used to get exposed to the other user. So how we had to do it we had to design our architecture in such a way that whenever data swap happens, the customer should get some error of data swap error like 515 so that my data is not getting swapped. So these are the different challenges we face when we work on performance system. Another challenge is circuit breaker. Whenever my system is not able to take too much load, there is so much of queue in the place. That time also we face so much of 500 series errors, right? Then also we need to make sure that in the low environment we check the circuit breaker testing so that we don't want to bombard the system with so many requests. So we can stop it in the initial layer itself instead of requests going to the server. If my server is not able to handle too many requests because of the traffic or because of infrastructure and dependencies. So this is the different challenges, but finally we had to come with a multi-threading architecture. So we were able to handle this too much load as well as data swapping. Mahesh.
Thank you. So, what can we do to fix the challenges that we have today? So there are a lot of opportunities to make the overall performance testing process a bit better. The key takeaway from this slide is I don't want you guys to read everything. The intention is not to explain each of the items here. The intention is to spot the opportunities that you have, right? So spotting the opportunities is very, very important, right? The way an enterprise company would conduct performance testing, the way a startup would conduct performance testing, but the kind of requirements a startup might have, the kind of requirements an enterprise might have is very, very different, right? You might not need a full-blown AI pipeline to solve some of the performance testing challenges that you have. That is very much common in an enterprise company compared to another company, right? So you don't have to build such a pipeline. The first and the foremost thing is to spot the opportunity. Where is your opportunity to solve something with an AI, right? It could be ML-based capacity planning. It could be clustering. It could be using encoder decoder, or it could be codeless script generation or whatsoever, right? Spot the opportunity. That's the key takeaway from this slide. And also, what is important to spot the opportunity, right? You got to understand, what is, for example, supervised learning, what is unsupervised learning, what is reinforcement learning, what are the various algorithms that are available under there, what do they actually solve for me, right? So you will also have to have a good fundamentals about those things. So again, it's important to be a generalist in terms of AI to understand the foundations, the fundamentals, so that when you spot an opportunity, it will be easy for you to tie back, what is that I can use with AI and ML algorithms that already exist that I can tie back to solve the problem, right? So that's very, very important. So a lot of things that we can do with AI today in the performance testing domain. So again, we'll have to figure out, where you have to start, what you have to start with, and then take step-by-step approach to build a complete pipeline for your performance testing. That's important. Again, these are some of the core techniques that you could leverage. It could be classification, clustering, LLPs, RILs, whatsoever, right? Like I said, again, the intent is not to go through everything, but to give you an idea of how you're going to do that, how you'll have to do it, right? So understand what it takes, where the opportunities are, where the gaps are, what AI/ML offers today, what are the various algorithms that I can leverage and start fitting to your flex. So that's the- Okay, user journey workload modeling. Again, going back to the same example I told, right? We had deployed our product in the S3 and it bombed, it failed. One of the reasons why it failed is we could not really replicate how they were actually using our product in our test environment. So what was happening was, the way we had tested in our test environment was we had created a scenario where it's going to log in, student is going to select the course, is going to register the course, and is going to log out, right? So we had done that, but what was actually happening in the customer environment was, there were bunch of first grade students, second grade students, third grade students. Some of them were browsing, some of them were selecting their subjects, they were keeping it ready. And then when the access window opened, everybody were clicking on the submit button, which could do the registration, right? So that was one of the key differences that we found out. The way our product was used in the production environment was actually very different than how we thought the product is going to be used, right? So what is important in the user journey workload modeling is to understand how your product gets used in the production environment, how are customers using your environment in the production environment, right? Not every time, for example, if you open Flipkart, not every time user will select a product, add it to the cart, do the checkout, and be done with it, right? And user might log in, he will do some browsing, he might stay there, and then he will come back, and then he'll do another thing, and then he will add item to the cart. Then he will start looking for the coupon code. Can I get 50% coupon code, right? So all those things are reality, right? All those things are reality, which you are going to be missing in your test environment, right? Or during your testing, right? So that is where it's important to come up with the workload modeling that will be as close to the real user, as close to what happens in the production environment compared to how you're going to design in a test environment, right? So again, going back to that example, so once we were able to simulate, then upon talking to the customer, we understood how the end users were using our product, what kind of workload modeling was in place, how they were actually pressing the registration button in just a 5 minutes window, where there used to be a lot of load coming into the system, right? So once we were able to simulate that, we were able to figure out, we were missing on database connection, pooling configuration. We had to bump up the pooling configuration. We had to introduce caching. We had to introduce, indexing on some of the tables and things like that, right? Which we were missing because we were not able to understand the workload pattern and the production requirement. So that's where it's important to understand the workload pattern and how to get the workload pattern from the production environments. So even before AI came into the picture, there were actually technologies that we could leverage with we could understand the patterns in the production environment. For example, there was a tool called Oracle RAT, Real Application Testing, where it could actually capture what would happen in the production environment and it could replay in your test environment, especially from a database standpoint, right? So all the transactions that could happen in the prod environment, Oracle Lab could actually replay in the test environment. So we were actually kind of leveraging those kind of things to see how we could bring back some insight from the production environment to the test environment, because there is always a lot to learn from the production environment, right? Not just for the testers, even for the developers, right? Even developers can learn how is my product being used in the prod environment? How is my feature being used in the prod environment? Because that's extremely, extremely useful. Even for a developer to succeed. If it doesn't understand how real users are using my product and feature, it's going to be very, very difficult for them. How AI can actually help with dynamic user modeling, right? AI can indeed help with user modeling because we have capabilities, we have algorithms that we can leverage with AI to build our workload modeling. So with AI, we can actually build a pipeline where, we can ingest the production log or the production data to the AI, and AI can start continuously analyzing the real user data from the production environment. And then it can start, segmenting, it can start creating clustering, it can start, creating defining the user journeys, and based on the pattern in the production data, it can also help define your think time, pacing, and a lot of detailing that is needed to build the actual workload model, right? It can help with the probability distribution, like it can say 30% are doing order management, 20% are doing payments, and another 20% are doing browsing and things like that, right? It can also segment your user personas, saying that 20% are quick with checkout, 20% are late with checkout because they've been browsing and not doing they're doing a lot of other things. And also, we can build a continuous pipeline which would, be iterative, which can detect changes between the test and the production environment and help you keep your workload model up to date, right? So that's a possibility. I would have shown a live demo how we could do that. It's not for the time constraints that we have, but what I did was I was able to quickly bring up Google Colab and quickly construct a pipeline. I just walk through the snippets how this can be done in a quicker way. But there are a lot of other ways, right? Again, the key idea is not to throw tools, not to throw algorithms, not to throw for framework, but to see ideas in your mind. This is doable, this can be done. You just have to figure out what is the right way for you to do, what's the best method for you to do based on your needs and requirements. So generating a synthetic log, so I use AI to generate synthetic logs. So typically these all were, production logs would look like, where it's going to have timestamp, user IDs, registrations, response times, right? I use NumPy and Pandas to quickly pull out the top 5 rows. So these are the top 5 rows of the production logs. And then, this will extract the key features, like sections, sequence of endpoints, average response time, duration of the session. So you could see, checkout, login, home, register, what's the average response time, what's the session duration start at the end time for each of the users. Again, aggregating user level features, it will cluster for clustering. Even before we cluster using unsupervised learning with k-means, you aggregate the user level features in this manner. Again, using Python code to define that and do it for me. It's going to define what the endpoints are, sequence of endpoints in various tables here. Again, this is another table where it's aggregating the user level features for clustering. And this will actually do the user behavior clustering using the k-means. K-means is an unsupervised algorithm. So this will do the user behavior clustering. So you can see cluster 1, cluster 2, cluster 3, cluster 4. The cluster 4 is doing registration search settings. Cluster 3 is doing add to cart, product view, profile, something. Again, user behavior clustering. This is just a visualization how it will look like. Cluster label for average session durations and everything. It will come up with the journey patterns like this. We can also segment into how many requests per day, per week. What sort of think times. right? And then finally, it will give you a workload profile like this. And this is the pipeline, where you're going to extract the session level features, you're going to aggregate the feature level for clustering, the behavior clustering, do the journey pattern recognition, then do the think time distribution, and then finally generate a reactive workload. So this pipeline can go on and on with your production environment, so you can completely automate. So that's the pipeline. So this pipeline can help you to dynamically learn from the production, define the user journeys, user personas, come up with a workload model, which will help you to conduct efficient load testing. Okay, AI-driven load generation. So typically the way we used to do load generation is, we used to define, okay, 1 hour test, this is the scenario where you log in, add item to a cart, and then log out, right? So you're going to run that for 500 users for 1 hour time, right? Typically that's how you used to do it. But with AI, that load generation can be dynamically done, right? How it can be dynamically done? For example, let's assume that you want to establish a benchmark on a specified set of hardware. How many users can it support, right? So what you will typically do is you typically start with 1,000, go to 2,000 users, go to 3,000 users, right? With AI, what can happen is it can automatically start taking decisions by itself, right? Based on what it looks at from the monitoring standpoint. If you have defined a load of 2,000 users that a particular environment is going to support, it could start a test with 1,000 users, do it for 2,000 users, and check all the the resource metrics, the CPU, memories, and everything. If it's fine, it goes down to 2,000, 3,000, 4,000, and then finally, when the CPU hits the ceiling, the AI can automatically stop and say, this is the benchmark, right? That's one pattern. Another pattern is AI can also automatically scale up and down the user load. Let's say, for example, you're running a load test, right? And you start observing that database is becoming the bottleneck, right? Database is getting slow. So AI can observe that automatically, and it will start increasing the load on the database so that we can exactly identify what is the root cause, what is happening on the database, right? So AI can't do that. So AI will start putting more load on database to find out, what is causing the database bottleneck, what is the reason behind that, right? So likewise, the load generation pattern that we can apply that can be completely controlled with transaction rate, user rate, scaling, virtual user scaling, controlling the think time and controlling the traffic, right? You can replicate your Black Fridays, you can replicate your peak days and weeks with load generation. And AI would take that decision based on a system resource, whether CPU is maxing out, memory is maxing out, or whatnot, or you define certain performance metrics that AI can learn. And AI can also look at anomaly detection and segment the response for that. So there are a lot of parameters that we can define to dynamically adopt and run the load test for that. That is completely practical and possible today. So an end-to-end pipeline would look similar to this, where you would have requirements that you're in your Slack, in your meeting notes or whatever. You will use NLP to form the requirements and feed it. And then feed it your workload modeling pipeline. So workload modeling pipeline will pick that up and create the workload model for us. And performance script generation, it's completely absurd. It's automatable today with Gen AI. So leverage Gen AI to generate a performance script. And then do like dynamic load generation that we spoke about. AI can also do anomaly detection and pattern. So based on that, it can vary the load generation pattern. It can also extend. It can automatically take a lot of decisions. Based on that, it can do adaptive adjustments. and also reinforcement learning. With reinforcement learning, you can do a reward system where if the AI system finds out that it can figure out, find out the bottlenecks based on certain amount of traffic that it can pump in. Like for example, if you combine order management, payment management, and user creation, there's a high chance of database going down, right? So those kind of things, the reinforcement learning can learn and do better as you train more and more. And this pipeline can run continuously with your test and the prod environment connected, and your system can get better and better at that. This is an example where typical load test and how the dynamic load generation would vary. I'm not going to go into details. Quick difference. AI driven can dynamically generate a load pattern for us. Traditionally, it's fixed. Scaling, it's self-adjustable because AI can completely write it. And also real world behavior, that's important because we're getting workload to the product environment. About me, I've been working in the industry for the last 22 years on various leadership roles. I've been fortunate enough to be part of a team where I have built software for some of the largest companies across entertainment, telecom, banking, and tech. I also love building communities, working with communities. I do a lot of community programs. And lastly, I've collaborated with a lot of startup founders, VCs. There is anything I can help, feel free to reach out to me on LinkedIn. Okay, I hope I'll just take one last one. See, the key takeaway is again not to throw tools, frameworks, or any sort of things. The key takeaway is think what is your problem today? How can I leverage what we have today? Where the gaps are, where the opportunities are. Right? So that should be the biggest takeaway from this presentation. Thank you again for